So in the last chapter, what we learned is how to calculate the mass of a molecule or an atom. And the way we did that is we looked at the atomic masses on the periodic table. So let's just look back at the periodic table real quickly. Let's do this one. And let's look at silicon right here, number 14, right? Silicon is right here. And I'll mark it so you can see it in case you're not seeing it. It's that guy right here. And it has an average atomic mass, and we learned that last chapter, of 28.085. Okay, so let me go back and we'll talk about that just a little bit. So SI is 28.085 atomic mass units. So if you have one atom, that's how much it weighs. And then we introduce the idea of Avogadro's number. So if I have a mole, and a mole is like a dozen, but it's just a much bigger number. 1 mole of Si, and 1 mole of anything for that matter, is 6.022 times 10 to the 23rd. In case of silicon, it would be silicon atoms. Okay. So when you have that, when you set that up, and this is the importance of the relative atomic mass scale for carbon, right? When you have that set up, then what you know is 1 mole of silicon, of Si, has a mass of 28.085 grams because of the way we set up our relative mass scale. So if you have 100 grams of Si, and you wanted to figure out how many moles of Si that was, then what you would do is you would say, well, moles is what I'm looking for, right? So I usually start with the unit I'm looking for, is starting with 100 grams of Si, and then I know the relative mass in terms of moles for Si, so I'm going to say it's 28.085 grams of Si for every 1 mole of Si. And that'll allow me, because look at how the units will cancel. When the units cancel, they go like this. That leaves me with moles of Si. So all I'm left with doing is the calculation. And I'll throw this up there real quick. I have 100 divided by 28.085. Right, and then I get 3.5, probably should look at that a little better, 6 moles of Si. Okay, so if I wanted, that's how I would figure out the moles of Si. Now, if I wanted to know the number of atoms of Si that I had, then what I would do is I would take the moles, so this is going to be atoms. Let me write what I'm trying to do. I'm going to go from moles to atoms. I'll start with the mole is what atoms is what I'm looking for. And I'm going to go 3.56 moles of Si. And then for every substance, this number is the same. Okay, 1 mole can go on the bottom of Si is equal to 6.022 times 10 to the 23rd atoms. Or whatever the unit is. So if this had been molecules, it would have been that many molecules. And so now I pull up my handy dandy calculator. I'm going to multiply that by 6.022 times 10 to the 23rd. And that's going to give me that number, not in scientific notation, so I'll figure that out. 2.14. Then we got to count the number of threes. 1, 2, 3, 4, 5, 6, 7, 8. So 24 times 10 to the 24. That's 2.14 times 10 to the 24 atoms. It's a lot of atoms, right? But again, this is how you would do this kind of conversion. I'll do another one. I'll add a page in here and I'll do another one. But if you want to go from grams to moles, you'll use the molar mass. This is true for every conversion. And if you want to go from moles to atoms, you're going to use Avogadro's number. That's this number here, Na. Usually what it's abbreviated. You're going to multiply it times Avogadro's number. Now you can do this conversion both ways, right? You can be given a number of atoms and then convert it back to moles, and that's what I'll do some of in the next examples. Okay, so what we're going to do is we're going to take 16.5 grams of H2O water, and we're going to convert that into molecules of H2O. So in order to do this, we're going to start with grams, right? And we're going to convert that to moles, and then we're going to convert that to molecules. Now remember, to go from grams to moles, it's always this number we call the molar mass, and that's the usual abbreviation is the mm. And then to go between moles and molecules, or moles and atoms, or anything like that, it's always Avogadro's number like this. Okay, and that's the usual abbreviation for Avogadro's number. So I'm going to say I want molecules. And I've been given 16.5 grams. You usually start with whatever number you're given, right? And then what I need to do is figure out how much 1 mole of H2O weighs. So what I need to do is I go onto the periodic table, and I'm going to calculate the molar mass. The first thing I want is molar mass. So I'm going to go over to my periodic table and show you these masses, right? So for oxygen, now your book says 16.00, so that's what I'm going to go with, but they round it to the hundredth. It's actually got several more places to the right, but most books will ignore that because it's not important for the concept, and usually your calculations aren't that far off. So 15.999, we're just going to call that 16, okay? I know that sounds a little crude sometimes, but that's a fat pen. And then for hydrogen, they're going to list it as 1.008, and that's the value your book uses. It's actually got more sig figs than that as well. So those are the masses that we're going to use. So we'll go back and we'll calculate with that. So I have H2O, so I'm going to have 2 times 1.008, and then because that's for the 2, and then for the oxygen, and that'll give me 2.016, and I'm going to add the oxygen to it, which is 16.00. When I add those together, I get 18.016, and we'll leave it at that, even though I should be rounding it to there if I was actually reporting that number out. So 18.016 atomic mass units, but that also means that 1 mole is equal to 18.016 grams. All right, so I'm going to go like this. This is going to be my conversion to, I'll do railroad tracks. This is going to be my conversion from grams to moles. I need to get the grams to cancel, so I'm going to put 18.016 grams at the bottom, and then 1 mole at the top like this, and this is of H2O. Now, to get to the molecules, then it's always Avogadro's number. And Avogadro's number, so this is step 2. You just have to remember Avogadro's number, 6.022 times 10 to the 23rd. Units, so I'm going to put units here, is equal to 1 mole. And the reason I said units is because then you can think of it as atoms, molecules. It could be cats, it could be dogs, it could be peas, it could be chickens. Like the word dozen, right? When you think about, I've got a dozen of these. If I said I had a dozen cats and a dozen chickens, you don't confuse that, right? They're like different things. But the dozen's still the same, and so the description mole is just like the dozen. So what I'm going to do is just much bigger, right? This is going to be 6.022 times 10 to the 23rd, and I'm going to use the word molecule because that's what water is. And this is going to be for every 1 mole. And the reason, again, why I set it up that way is so I could get these units to cancel out. And then these units will cancel out here. And so what's left for me to do is to run this through my calculator. And so I'll go ahead and do this. So I've been doing calculators for a long time. And so I just kind of know how they work. But sometimes people, when they're first starting, uh, are not really good with these calculations. So I'm going to show you two different ways, and we'll see that we get the same answer, right? So I'm going to go 16.5 times 6.022 times 10 to the 20. Oops, wrong button. Sorry. 16.5 times 6.022 E23, and then I'm just going to divide by 18.016, like that. And that'll give me that number, which is this giant number. Oh, look, they got a button now. That didn't used to be there. So now that's 5 point, oops, let's see, what is it? Actually, 5.52, I'm rounding, times 10, and then the exponent on that is right here to the 23rd. Okay. Now, I'm going to show you another way you can do this calculation, because this is one of those things that I usually do. As I read the problem, when I hit something at the bottom, I just hit divide, and then I hit multiply if it's at the top, right? So I'm going to go 16.5 divided by 18.016 times 6.022 times 10 to the 23rd, and I'll hit equals, and I get exactly the same number, right? You see that that's 5.52 rounding to the 10 to the 20 times 10 to the 23rd. Remember, multiplication, division, orders of operation don't matter. Whichever makes you happy, that's fine. I like to go from left to right so I don't miss stuff. Sometimes if you go all the way across the bottom and then you start dividing by stuff on the bottom as you go along, because everything at the bottom you have to divide by, sometimes you miss stuff. So I like to just do it as I go along. Okay. So let me show you another example. That was, again, another example of grams of something to molecules of something using Avogadro's number. Let's do this. We're going to do 1.53 times 10 to the minus 15 molecules of, let's do H2O again. Or actually, let's pick something else. Let's do C6H12O6, like this. So glucose, glucose molecules. And we want to convert that into moles. Or let's do grams. Let's do that into grams. And so we're going to go all the way the opposite way. You recognize over here in this first problem, I started with grams, and then I went over and calculated all the way over to molecules. So now what I'm going to do is start with molecules and go all the way over to grams. Okay, so again, the path is this exact same pathway that I showed up here, but backwards, okay, going the opposite directions, because I'm starting with molecules. I'm going to convert it over to moles, and then I'm going to convert it over to grams. So again, the conversion between molecules and moles is always Avogadro's number. What changes is whether or not it's in the numerator or the denominator, so that you can get units to cancel out. And as it turns out, if you go one way, they'll always be on either the top or the bottom, and then if you go the other way, it's always reversed. Okay, you'll switch it, and you'll see that in this problem. Now, between moles and grams, then what I need is the molar mass, right? So we're going to have to calculate molar mass again. But it's not the molar mass of water now, it's the molar mass of glucose. It's the molar mass of that guy, and it's pretty big, okay? So again, the first thing I'm going to need in all of these kinds of problems when I go between molecules and grams or moles and grams is I'll need that molar mass. So I have C6H12 and then O6, like that, right? So that's the first thing I'm going to calculate molar mass. So I'm just going to write these down. I have them memorized. So 12.01 grams, right? Atomic mass units, sorry, for carbon. So I'm going to multiply that by 6, right? Because there's 6 of them here. And then the hydrogen is 1.008 AMU, and I'm going to multiply that by 12. And then the oxygen is 16.00 AMU. and I'm going to multiply that by 6, okay? And then I'm going to add all that up, and yeah, I'll just use this one here. So let's move this out of the way so you can see it anyways. So I'm going to go 12.01 times 6 plus 1.008 times 12 plus 16. And, you know, it's 0, 0, so you don't have to put the 0, 0 times 6 like that. And so that looks like it's going to be right? 12.01 times 6, 1.008 times 12, 6 times 16 times 6, and I get 180.156 atomic mass units like that. Okay. Oh, by the way, I didn't mention this. If you get tired of writing AMU, U is the abbreviation for AMU. It's like the only abbreviation I know that has an abbreviation. Anyways. Okay, so that's good. I needed that. And the other thing that I'm going to need is I need to know Avogadro's number, right? And 1 mole of C6H12O6 is going to be equal to 6.022 times 10 to the 23rd. And I don't believe put the word mole in, but it's molecules of C6H12O6 like that. So basically all I'm doing is saying 1 mole is equal to 6.022 times 10 to the 23rd. All right. Now, let me go ahead and set this up. I want to know grams. Oh, sorry, this is plus 15, not minus 15. I want grams, and I'm going to go 1.53 times 10 to the 15 molecules. And try and not use MOL and MOL for moles and molecules. Some people get in that habit and they get confused like where they are in a problem because they've used the same abbreviation for each. So now I'm going to do 6.022 times 10 to the 23rd molecules. So that's the C6H12O6. And you could have written that here as well, okay, for every 1 mole of C6H12O6. And then I need to continue this calculation on here. So I'm going to be multiplying that. Now I've got the molecule part canceled out. I need the moles to cancel out, so that needs to go on the bottom. And on top, I'm going to use 180.156 grams. Because remember, this number, in addition to being representative of atomic mass units, is also the mass of 1 mole of glucose molecules. And so now I can pull that out and calculate it. So let me grab my handy dandy calculator. And then I'm going to say 1.53 times 10 to the 15 divided by 6.022 times 10 to the 23rd times, because I'm over here now, 180.156. 180.156. And I'll check. Well, and unfortunately, it writes them out as like without scientific notation, but that looks like it's about right. I hit equals, and then I get 4.58. That's what I'll use. 4.58, and then times 10 to the minus 7. And my units are grams. So it doesn't weigh a lot. 10 to the minus 7 grams, that's less than a microgram. Your hair probably weighs hundreds of times that mass. So anyways, a single hair, I should say. That's how you convert back and forth. Now, if you didn't need, let's say you wanted to go from molecules to moles, then you can just leave out this gram to mole conversion. And if you wanted to go from grams to moles and not all the way to molecules, you just leave this Avogadro's number conversion out. So I showed you some longer conversions, but if you need the shorter version, then you just stop a little sooner and then calculate your answer.